Worksheet 5J, question number 3, solving algebraically. Vector A has been given a value of 5.5 centimeters or 5.5 newtons. It has been measured to be pointing in the direction of 75 degrees north of east. Never eat soggy wieners. So it starts here, east, and moves to the north. B has been given a value of 5.0, and its angle here has been measured to be approximately 55 degrees. And again, if we put the crosshairs, never eat soggy wieners, it's east but turning south, south of east. Green here represents the resultant R. If we understand that the cardinal directions north, east, south, and west are 90 degrees to each other, then we can see that this angle being 75 degrees makes this angle here, we'll denote it with a circle, is 15 degrees. Using the Z law, if this north to south is parallel to this north and south, then this angle here is also 15 degrees. Now if we see that this angle here is 90 degrees, east and south, and this component of it is 55, this makes it 35 degrees. This angle in total is now 50 degrees. This angle is vertically opposite side R. We know side length A, B, and angle R, theta R if you like. That means we should be able to calculate R using the cosine law. The cosine law can be written down as c squared equals a squared plus b squared minus 2ab cos c, angle C. We're going to do our substitution. We're solving for R squared. A and B are arbitrary, so let's just keep it consistent, and we'll go VA squared plus VB squared minus 2VA VB cos, and we're using theta R. Continuing with our subbing, it's 5.5 squared plus 5 squared minus 2 times 5.5 times 5 cos 50 degrees. R squared equals 5.5 squared $30.25 plus 25 minus 2 times 5.5 times 5 times 50 cos. And that's approximately 35.35. R squared is 55.25 minus 35.35. R squared equals, so we'll just change this to a negative and add 55.25, and we have 19.90. Square root that, and we have we'll square root that, and we have R equals 4.46 newtons. Now that we have R's value here as approximately 4.46 newtons, we now know R, we know angle theta R, we need to figure out this angle that R is moving off, the direction. We can calculate that by looking across to the side length VB. Using the sine law, solve for angle theta B. We're solving for the angle, so let's go sine theta B over side length B equaling sine theta R over R. We're going to multiply both sides by vector B. That makes 1. So we have sine theta B equaling VB sine theta R over R. And to get theta B by itself, we're going to take the arc sine of VB sine theta R over R. Theta B equals arc sine VB, which is 5, times sine theta R, which is 50, and we're going to divide that by side length R, which we calculated to be 4.46. So theta B equals arc sine, let's figure out what 5 sine 50 is. 5 times 50 sine, that's approximately 3.83 divided by 4.46. 0.46, and we have arc sine 0.86 approximately. Arc sine 0.86 gives us the angle theta b is 59.3 degrees. 59.3 degrees is this angle here. As measured earlier, angle A was 75. Therefore, theta R2, we'll call this one theta R2 to differentiate it from theta R1 here, is equal to 75 minus 59.3 minus 75. Theta R2 is roughly 15.7 degrees. Our final answer is R is equal to 4.46 newtons, 15.7 degrees, and it's touching east, moving north. North of east.